Alright, hey everybody. We're going to talk about voltage, current, and resistance, just the basic definitions of it, and then introducing Ohm's law. So voltage is, one way to think about voltage is thinking about it like stored electricity. And the unit for this is actually going to be in volts. And another way of thinking about this is the potential energy when we're talking about electricity. So some of us like to relate this to potential energy. And potential energy, or just thinking of it like energy that's stored, that has potential but is not yet released. And it is released when we're talking about current. And current is essentially the flow of that electricity. And if we're comparing that to energy again, that would fall under kinetic energy. And current's always measured in amps. So voltage is essentially that stored electricity. So when you're thinking of voltage, just think of the battery. You hear a 9-volt battery all the time. So you see these block-like batteries right here with my poor drawing of it. So these are essentially descriptions of how much electricity is stored within that battery. And then current is essentially the flow of that electricity. So let's say there's a wire that's connecting out and it's going somewhere. That electricity flowing through that wire is the current. So as it goes through there, that's a current. And we have something called resistance. Resistance essentially impedes the flow of electricity, or impedes the current. And resistance is measured in ohms. And there's also a symbol that you might see commonly for this, which is omega. So resistance resists that flowing electricity. And a lot of times you would want to do that because you don't want things that are essentially, in simplest terms, too strong for whatever it's trying to power. So one way of drawing resistors in the circuit is actually like this. So kind of like an EKG line or just some hard squiggly lines. This is essentially the resistor. So the voltage, stored electricity, current, flowing electricity, and resistance is impeding that flow. And in this drawing, let's cap it off by, let's say, a light bulb. And then it's going to, this is actually an incorrect drawing. It would go back into that wire. So this would actually just go on one side, and that's how it would look. So here's that light bulb. So if I were to come up with an analogy for this, I could use a toilet. So let me go ahead and draw my toilet. So here's a toilet, and inside that toilet there's some water. And when I flush it, let's say it travels through the pipe and outside of your house and into this water tank. And in that water tank, we're going to filter that water and then bring it back over. So here, just think of this stored water as the voltage. And as it flows down through the pipe, that's the current. And for resistance, let's say that I don't want that water going in too quickly. So I'm going to go ahead and actually erase this. And I'm going to draw a modification into my pipe. So I don't want it going too quickly. So I'm going to put this little thing right here. And what it does is this slows water down. So, as I said before, resistance impedes the current or electricity flow. So here, if this is slowing water down, that would be the equivalent of a resistor. And ultimately, it's going to come back in and it's going to fill your toilet bowl. So this isn't actually how it works, but this is an example of what voltage, current, and resistance would kind of look like. And this is really important for us to understand if we ever want to go into electrical engineering, and let's say we have current and we have resistance, but we don't know how big of a battery we want to use. Or let's say we know our battery size, right? Let's say we know our battery, and that battery is going to go, and it has a resistor. And then let's say there's a light bulb here, and then it'll go back into the battery. Now let's say we know this is 9 volts, and let's say that we know that the current is going to be, let's just say 0.27 amps. How much resistance do we need? This is something that we need to figure out, because we need to learn how to calculate essentially what resistor type we need and to be able to look for that. So this is an introduction to something called Ohm's law. There's going to be another video on this so that I can go more in detail, but essentially we can use this triangle to describe Ohm's law very clearly. So let's say we have a triangle V, I, R. So how it works is, let's say I don't know resistance. So if I don't know resistance and I want to find that, what I'm actually going to do is, let's say you cover up resistance. Now you have V divided by I. And let's say you don't know voltage. So let's rewind all of that. And let's restart for voltage. Let's say you don't know voltage, so you set V is equal to, and you see that I and R are next to each other, so that'd be I times R. And this is actually Ohm's law right here. And just being able to understand this triangle and understand how to read that triangle is very important, because it tells us a lot of different things. Here, it tells us we can find voltage, we can find current, we can find resistance, all by looking at this triangle. So that concludes the introduction to voltage, current, resistance, and Ohm's law. So there will be another video on Ohm's law, diving more into practice problems.